Solving equations in one variable, Chapter 2, Lesson 7. So our definitions today, we have what is an extraneous solution? That is a solution that is not actually a solution of the original equations. So we might solve and get a couple solutions, but when we sub them into the original equations, we find out that's something that x cannot be. Then we're also going to solve rational equations today. So rational, remember, means fraction. And in order to do that, we must have a common denominator in all of our fractions. We're going to find the least common multiple, and we might have to do some factoring. And then once we have the all the denominators to be the same and the numerators multiplied by those denominators, we can then cross out the denominators and solve what we have left. So we're starting here with solving x plus 2 equals 15 over x. And the first thing we're going to want to do is make the left side into a fraction. So I'm just going to put it over 1. And then I'm going to want to make common denominators. So I need to multiply this one by x, top and bottom. Once I have common denominators, I can cross them out and then solve as normal. So distributing on this one would give me x squared plus 2x equals 15. You can solve by any method of your choice. I feel like I haven't done the quadratic formula in a while, so I'm going to go ahead and solve it by quadratic formula. A is 1, B is 2, C is negative 15. Go ahead and check my discriminant real quick here. 2 squared minus 4 times negative 15, 64. Which leaves me with negative 2 plus or minus 8 over 2. So negative 2 plus 8 over 2 and negative 2 minus 8 over 2 would give me 3 and negative 5. Then we'll just check both of these real quick to make sure that one of them doesn't give us a non-real solution. So if I substitute negative 3 into this equation in both x's, positive 3, excuse me, I'd have 3 plus 2 is 5, and 15 divided by 3 is 5, so that works. When I sub in the negative 5, I have negative 5 plus 2 is negative 3, and 15 divided by negative 5 is negative 3. So both solutions work. On the second one, the first thing I'm going to do is make 4 into a fraction. I'm going to make it 4 over 1. Now, one thing to know in this section is that when I have a denominator of x and a denominator of x minus 3, there's no way I can just add a negative 3 to get them to be like denominators. You have to do it by multiplication. So there's nothing that I could multiply x by in order to make it x minus 3. So I'm just going to have to think of them as a monomial and a binomial that need multiplied by each other. So I'm going to multiply this one by x minus 3, and whatever you do to the bottom, you must do to the top. And then I'm going to multiply this one by just an x, and now those two have the same denominator. Now the 4 will then need to be multiplied by both the x and the x minus 3, so that all of my fractions now have the same denominator. Go ahead and cross them out. 1x minus 3 minus 2x equals 4x squared minus 12x. When I do all my distributing, remember this subtraction sign here belongs to that 2x, which is why I said minus 2x. Then I have negative 3 minus 1x equals 4x squared minus 12x. Set it equal to 0. So that would give me 4x squared minus 11x plus 3 when I add my 1x and add my 3. I'm going to go ahead and do this one by window method because I feel like it's been a while since I've done a window method. So remember, in the window method, I'm going to put 4x squared and my 3 And in my circle, I'm going to put 4 times 3, which is 12. So I'm actually looking for factors of 12 that add up to 11. Of which there's none, right? 3 and 4 make 7. 2 and 6 makes 8. All right, so I guess I should have done this one by quadratic formula. Cannot window method it. So 11 plus or minus the square root of 11 squared minus 4 times 3 is 73, which is why we couldn't window method it, all over 2 times 4, which is 8. And I'm not sure on this one if we're supposed to be giving decimals or not, so I'm going to go ahead and leave it like that, but also give a decimal. So 11 plus the square root, forgot the plus, the square root of 73 divided by 8 is about 2.44, and 11 minus the square root of 73 divided by 8 is 0.31. I'll fix that real quick. 0.31 is what I was trying to write. Okay, on this third one here, I see the first two are in binomials, and the third one is a quadratic, which I need to factor really quickly. Factors of 4 that subtract to be 3 are 4 and 1. Sign chart is they should both be minus. Nope, bigger one gets a plus. So as you can see, this first one already has the x plus 4, so it's only missing the x minus 1, top and bottom. And the second one has the x minus 1, so it needs the x plus 4. And now my denominators are all the same, so I can cross them out and start distributing. 4x squared minus 4x plus 3x plus 12 equals 15. 4x squared minus 1x minus 3 equals 0. This one I for sure can window method, so let's try this again. 4x squared and 3. I'm looking for factors of 12 that subtract to be 1, which are 4 and 3. Sign chart says the 4 is a negative, the 3 is a positive. They have in common here 4x plus 3 and x minus 1. If I solve them for 0, I get x to be negative 3/4 and x to be positive 1. Now I just remembered I didn't sub any of these last decimals into my solution to figure out if they wouldn't make it work. But if I go back to the original solution and I look at where x is, it kind of gives me a clue. Looking at the denominators, I know that x could not be 0 or 3, which neither of those were. So I'm okay. Those both solutions will work in this equation. However, when I go back to this original one here, first of all, I know that positive 1 would not work. And I knew negative 4 would not work, which is not my solution. And then I'm going to go ahead and check my negative 3/4 squared. Oops. And so I'm good on that one. Just wanted to check that one to make sure that it worked, and it did. So you're installing a pool in a yard. The pool is a 1,000 square foot rectangular shape with a 2-foot sidewalk around the perimeter of the pool. Space is a problem, so you need to find the dimensions of the pool and sidewalk that will take up the least amount of space. Find the minimum square footage, find the dimensions and the minimum square footage. So I know that I have a rectangular pool with a 2-foot sidewalk around the pool. All right, I'm guessing this 1,000 square foot is probably my area. So I'm going to let 1,000 equal x times y. So I'm going to let this be x, and nope, right here be x. And this be y. But I need it only to be in terms of x, so I'm going to say that y is equal to 1,000 divided by x. Now, I know that the length of the pool here then would be 1,000 divided by x plus 4, because I have a 2-foot sidewalk here and a 2-foot sidewalk there. And then my width here is going to be x plus 4, because again I have a 2-foot sidewalk here and a 2-foot sidewalk there. So my total area of my pool and sidewalk will be x plus 4 times 1,000 divided by x plus 4. And if I'm going to find the minimum square footage, I'm going to put it into my calculator here. Try to get the graph to show me. Let's go 50. Let's go 100 on my X max. And let's go 5,000 on the Y. And it says find the minimum square footage. So second trace minimum. I don't know if that's a true minimum. Oops. $13, $14, $13.07, $13.01, $12.96, $12.91, $87, $80, $78, $76. See, my Y value is still going down. Oh, here. No, 68. Oh, there it was. Around there. 69, 68, 69. Okay, let's try it again. Okay. X is 31.63 and Y is 1268.98. So the minimum square footage would be 1,268.9 feet. And then for the dimensions, if I know X is 31.63, that would be my width. And I know that my length is 1,000 divided by 31.63. Ends up being 31.63 also for my length. And then that's just my pool. But if I add the sidewalk to both of them, it'd be 35.63 for both of those.